Thank you. I'm Renat. I work for MZ, and I will be talking about our open source product, which is MZBench, and the language, Lisp-like language we have inside of it. So the presentation plan would be like this. I would explain our workflow, basically what our system does, then why do we need the DSL, and then how did we do that. So some milestones. And basically, it's about, our product is about some different Erlang applications and the front end. And usually there's a designated API server, which is deployed somewhere in your network. And you interact with this server with CLI or using web browsers. It has a dashboard as well. And also we assume that a target system, which are going to benchmark, is deployed somewhere separately. So it exists, you deploy it using some other tools. To start a benchmark, you send a request or push a button inside a dashboard, and then API server starts its work. Usually it requests some nodes from cloud provider, it's EC2 usually, and then start to provision these nodes. It's by copying its code, which we call MZBench node, and also a protocol-specific code, which is used to generate some load on target system under test. For example, if it's HTTP server, then it's going to be some HTTP worker which requests get, put, and so on, other HTTP packets. After the provision is done, there's an interaction between a benchmark cluster and the target system, which produces some results. Results are merged through director node, the designated node, which performs all the coordination and sending all results to be displayed at the API server. And the client usually sees some charts, some log information, and so on during this interaction. And after everything is done, server deallocates all the nodes requested from a cloud provider and free them for any further usage. And if it was requested, some email is sent with the reports. And the part which is described by DSL is interaction, which was on the previous slide, like this. And after all information is available, like in database, you could request it, watch some logs, compare some results when your target system even offline, when your cloud controller basically not supposed to work that way. This time, I mean, so everything is browsable. It was quickly about how it works. So here's the main question: why do we need a DSL? Because a lot of systems work without. We think that it is interesting to have 4 levels of expertise. I mean, if you have some tests for HTTP server, usually these tests about creating some sort of load with a certain amount of requests with some certain packet sizes and so on and so on. And if you have such a test, usually a non-qualified developer could change some rates, message sizes, and for example, increase testing cluster size without knowing anything. They are usually like parameters to the command which you are running, and it is simple. To increase time, you type something like -- time equals 120, and then you increase time. But if you need to do something more, if you need to send some kind of different packets if you know, for example, that some problem could occur if your length is divided by 100, for example, it could be harder to get adjusting only these parameters, and you may need some certain of some kind of warm-up procedure for your servers and so on. So changing scenario, in the case when you describe your scenario in the same language as your system, requires knowledge of this language. In our case, for example, it requires to know Erlang. But it's not really hard to master if you compare with different languages. But if we came to a game developer and asked him, could you please run a benchmark on your code, but here's our language, and you need to know Erlang. And he said like, oh, I'm a Lua programmer and I don't understand all this stuff, so could you please do it by yourself? So we just want to not be in charge for running bench scripts all the time because we wrote the system. We want to make this as a work of someone else. And also we added ability to write new protocol, not only in Erlang. To implement some particular database, you could specify it in Python and so on. But in order to change some core functionality, unfortunately, you need to know Erlang because system is written in Erlang. So we think that our language is limited, but limited in a good way. So if you have only 10 different operations that you could do, it's easier to master, probably. Of course, you could mention brain fuck. It's not easy to master because of small set of operation, but it's not this case. And you don't need to specify all this information gathering, which we do during the benchmark. You don't need to specify that you need to gather or CPU load information and so on, and that you need to summarize all counters and so on. All this is done implicitly. And also, which is important, a person who works on a test scenario could not affect some system parameters, could not affect system scalability. Because if you give people ability to write test scenarios in Erlang, they quickly create a Gen server and make a call. And once you start benchmarking with 100 nodes, it just stuck. And you spend a lot of money, but your benchmarking is not doing anything. So if you limit this benchmarking to a small language, you could avoid these situations. And we actually perform all static analysis, like synchronization, primitive analysis in our language, which is, of course, possible in pure Erlang, but it's much harder. So in our case, we have a small set of operations, and we just basically create a graph and check for the loops inside of it. And it's pretty straightforward to analyze language when it's really small. So it was our reasons. And how did we do that? For the first version, we used file consult because when a project takes a long time for the first version, it's bad. I think it's bad. And it took about a month to create some first prototype to use inside a company. And it's been 2 years that we're running this project. And the first version was really simple. As you see, it's a Lisp-like language. It's not really a Lisp. It's Erlang terms. And this thing is called embedded DSL, and It means that the language is described inside the syntax of your host language. Of course, it is possible in other languages, even in JavaScript and whatever. But what's good about Erlang that we have atoms here, and some operations look nicer. Here's what it does. The first statement is assert. It tells that HTTP OK request per second should be greater than a half always. Then the second is about installation of some particular soft required for benchmarking. And then goes the script, which described how much workers should it be, and then worker type, and then something like a loop, which lasts for 120 seconds, and the increase of loop rate linearly from 1 RPS to 200 RPS. So from our point of view, this kind of language is easy to read if you a little bit familiar with Lisp and you don't afraid that you have two different types of brackets here. If you could master them, the hard part is the ending when you have a lot of. But once you use some sort of editor, it became easy. So it was our first version. Then we realized that we need more detailed error messages. Once you have a problem in your script, you need to tell a user where is the problem. And you could tell like, oh, look inside your loop. But it's better than it's better to mention where is the loop. So in order to get line numbers, we used some other functions which are shipped with Erlang, and it's good. You could parse into intermediate language, which is here. And as far as I know, it is not described anywhere. But if you look at this language, intermediate language Erlang has for terms, for parsers, it's kind of easy to master. And since the first version, it was Erlang 15, nothing has changed there, luckily for us, because they, as they don't describe this language, they could break compatibility anytime. I realized that, but it doesn't get broken. And then you transform these terms to get line numbers in an explicit way, so you could use them in your error messages. For example, you could watch our code as open source, or you could ask me, I could point you where it is. And then we realized that having an Erlang on all nodes is too much. I mean, that we use CLI to start some tests, and it should be run from any system, not only our laptops, but from a computer of a random test person. And we decided to write lightweight CLI in Python. And it turns out that it wasn't hard to implement all grammar that Erlang terms have in Python. We did this in about a day. And we also open sourced this project. It uses parsimonious Python parsing library, and it basically parses all Erlang terms. So they are available from Python, and we do some small part of analysis from there. And the last step front was adding additional front end. So people were saying like, oh, your scenarios are in Erlang. We said, no, it's not Erlang. It's more like Lisp. No, it's Erlang. We see that. It's weird something. And we decided to implement additional front end, which looks like more looks like Python. And it is translated to the language as you see before. is our kind of Lisp, and then got executed. And it turns out that it wasn't really hard as well. And what I like in this process, we don't destroy and rewrite everything from the beginning. We on each step we use what we had before. And in this case, we got this kind of language. We use parsed library, parsed Erlang library. I'm not sure about the name. I'm sorry, I forgot. But right now, it's ident-based language, and it's much easier for game engineer to understand what's going on. We have the same constructs, same things as I showed previously, is asserts. We have measurement units here, like 30 seconds, like it was before, and some things like loops and pools. So it's still description language. We still have features that we had before, but it is easier to read. And the reason why it's not Python, as I mentioned, to prevent user from making random things and analyze them after. So to conclude that our DSL is limited in a good way, easy to analyze because it is limited and expressive, and also infrastructure independent. So you could start the same script on your local host or on a big cluster, because there's no problem in scaling it out. Sometimes, of course, sometimes it could be a problem. Of course, if you want to create something which doesn't scale and you think hard, you could. But usually, you're limited and you could not. And our tool is cloud aware. I mean, it itself requests a cloud for nodes, allocate them. Extendable, I mean, it's easy to add some cloud or protocol. Scalable, we even removed Erlang message interaction between nodes to make it scalable between different data centers, because Hypercube topology doesn't scale well. So we implemented our own protocol, and each of the nodes is on a separate environment. So we have metric system and Python and Lisp-like DSLs for scenarios, and Lisp-like come first. And Erlang Lua for extension. For Lua, we use Robert reading Lua. And for Python, we use a separate Python interpreter. So if you have any questions, there's a minute.
I think we're a little bit behind.
Okay.
So, hang on. Yeah, there we are. I'm afraid we'll be running a little bit late, but might have time for one question. Anyone? Well, in that case, thank you very much.
Thank you.